Lesson 1.3.1, how do we apply formulas for non-right triangles to solve problems? Is a lesson essential question. You all remember some of these formulas from geometry. We have law of sines, law of cosines, and today we have a new area formula. The area formula that you know and love, 1/2 base times height, only applied to right triangles. Well, what happens if we don't have a right triangle? What can we do? Okay, well, first of all, we're going to take a look at this problem. This is the proof for the new area formula here. Okay, so since side angle side determines a triangle, it should be possible to find its area given two sides and the angle between those sides. Since the letter A is already used as a vertex of our generic triangle, we're going to use letter K to denote the area of this triangle. So we're looking for K. Writing expression for K, the area of triangle A, B, C, pictured here. Okay, well, first of all, K is going to have to equal 1/2 the base, which in this case is little a. Okay, this is the base, times h, which is the height. Now that's all fine if we know what the height is. So what if we don't know what the height is? What if this is a mystery here? Okay, what if we just have this triangle? Okay, now using angle C and the hypotenuse B, find an expression for the height h. So using angle C, okay, hypotenuse B, we're trying to write an expression for h. H, if I'm here at the angle, h is across from me, so it's opposite, so I'm going to use sine. So the sine of angle C is going to equal opposite h over hypotenuse B. Okay? Now it says find an expression for the height h. That means we should get h by itself. So to get h by itself, I'm going to have to cross multiply, and I get h equals b times the sine of C. Last, combine my results from part A and part B to find a formula for the area in terms of angle C and sides AB. So if I take h and substitute it here for h, I end up with an area K equaling 1/2 AB sine of C. So if I have side, angle, side, I can find the area. All right, side, angle, side. New area formula for non-right triangles. Copy that in your toolkit. Two adjacent sides of a triangle are 4 centimeters and 6 centimeters in length. The angle between them is 76 degrees. Use the formula you found in part C of the last problem called side angle side formula to find the area. So draw your arbitrary triangle. 76 degrees is the angle. Side 4 centimeters, side 6 centimeters. Area is going to equal 1/2 A, B, sine of C. Calculator, again, make sure your mode is in degrees. So, calculator on, not coming on, that's good too. Reset calculator. Okay. So, mode, degrees. You'll learn that. Yeah, that's something we're going to have to check every day. So we have 1/2 times 4 times 6 times the sine of 76 for an area of 11.64 units squared. So area equals 11.64 units squared. We just arrived, which means proved a formula for area of triangle ABC in terms of side B, C, and angle A of an acute triangle. We did not consider what happens when the triangle is obtuse. Use the diagram at the right to prove the formula above works for the obtuse triangle. So all these ideas are still the same. The sine of this side, the sine of that angle is still going to be, the opposite side of the right triangle over the hypotenuse. So everything still applies. Okay, so you can still use this formula for an obtuse triangle the same way we did the proof in problem number 90 for the acute triangle. So there's no work necessary for this problem. The formula is still going to be 1/2 A, B, sine of angle C, or it could be 1/2 BC sine of angle A. Now, any combination of side, angle, side will work. It just depends on which side, angle, and side you've been given in the problem. Use what you have learned about area to solve the next problem. Tomas, an eccentric man who loves triangular shapes, was in the process of building his dream home. Of course, it was to be built out of triangles. In this case, Tomas was building a workshop with a square floor and triangular sides of length 10 feet from the base to the top, with an apex of 40 degrees. Find the surface area of the sides of his workshop. So the first thing we need to do here is look at each triangle, which has an apex angle of 40 and legs of 10 and 10. First of all, it's an isosceles triangle. Not that that matters in this particular problem, but we got to find the area of that triangle. So it's a non-right, so we're going to have 1/2 A, B, sine of 40. Go ahead and type that in your calculator. All right, so we get an area of that triangle of 350.32 units squared. And it's feet, so feet squared. Now, if it's a square-based room, how many of those triangles then are there? Okay, there's 4 of them. So we're going to take that area times 4. So go ahead and take your answer there, times 4. And we get a total area, surface area of 1401.28. 1401.28 square feet. Okay. It says here, find the surface area of the sides of his workshop. So sides, I'm assuming, would mean walls. Okay. It does not ask to find the surface area of the floor. If it did, however, you'd have to find this third side of the triangle. So that would be law of sines, which we didn't quite do yet. You should know from geometry, but we don't yet to find that particular side. So this is what we're going to stick with here: area of the sides, the total. Next is law of sines. Figure at the right, we use letters A, B, and C to denote the sides opposite of angles A, B, and C respectively. Use a diagram to complete the following problems, given that triangle ABC is acute. So write an equation to express H in terms of angle A and side B. Now typically when you're proving something, they would not guide you step by step here. However, this is intended to be a classwork problem. I'm going to guide you through it. Not only that, but you also have the guidance in the book. Typically a proof would mean that you prove it on your own with no help. So write an equation to express H in terms of angle A, side B. Well, anytime we're combining angles and sides, we're thinking about trig ratios. So put yourself where angle A is. Okay, we're using side B and height H. Height H is opposite of you. It's across the triangle from you. So that's going to be sine. So the sine of angle A is going to equal H over B. But now it says write an equation to express H. If we're expressing H, it should say H equals. So you're going to have to cross multiply and to determine that H equals B times the sine of A. Part B. Let's write another equation to express H, but this time it's going to be in terms of angle B and side A. So now we're looking at angle B, side A, and H. So same process, sine of B equals H over B. Excuse me, equals H over A. Sorry about that, typo. So again, express in terms of H. So H equals A times the sine of B. Well, this is no different. It says here in part C, use your results from part A and part B to show that sine of A over A equals sine of B over B. Well, these are the two equations we have. So going back to algebra B, equal values method, if H equals this and H equals that, that means this and that equal each other. So B times the sine of A equals A times the sine of B. This looks a lot like law of sines, but not quite yet. So in order to get this to be or look like the law of sines, we would have to divide both sides by b and divide both sides by a. And in doing so, these a's cancel, these b's cancel, and we end up with the sine of a over a equals the sine of angle b over side b. Okay, so now if you drew an altitude to BC instead, follow the same method, what would your results be? No different there. We're just looking at sine of angle b over b, but this time it would be equal to the sine of angle c over side c. And that is where the law of sines comes from. A triangle is labeled PQR. Draw a figure that represents the correct placement of sides angle or sides PQR. So if we have angle P, angle Q, angle R, it is specific. The side is across from its respective angle. So that's what it would look like here. Okay, then write the law of sines for this figure. A lot of students struggle. You know, A, B, C, all of a sudden we got P, Q, R. Well, law of sines though, I don't have angle A. Well, sure you do. It's always the angle over its opposite side. So sine of Q over side Q, sine of R over side R. It's always the sine of the angle over its corresponding side or its opposite side. Okay, number 96. Oh, law of sines, math notes. Copy that down. 96. Nathan lives 200 feet downriver from Tong. Both live across the river from Amy. Nathan views the other two houses at a 100-degree angle, while Tong sees them at a 38-degree angle. Find the distance between Nathan and Amy's house. Okay, so first of all, Nathan lives 200 feet downriver from Tong. Both live across the river from Amy. So that means this is Amy's house. Okay, it says here that Nathan views the other two houses at a 100-degree angle. So this is Nathan's house. Big Nate. Big dog! And this is Tong's house. Okay? Find the distance between Nathan and Amy's house. So we're looking for this distance here first. Okay? So first of all, the test that we're always going to do to know whether we're using law of sines or some other law of cosines particularly is determine, do we have an angle and its opposite side? In this case, that is what we're looking for. Okay? However, this angle and this side are not opposite of one another. But using some geometry, some very basic geometry, we can find this angle here at Amy's house. So if Nate's angle is 100, Tong's angle is 38, we're looking for what remainder there would give us 180 degrees total. So the angle at Amy's house, so angle A, ends up being 52 degrees. So if I set up my law of sines, I would have the sine of 52 over 200, again, angle opposite side is going to equal the sine of 38 over x. Cross multiply, and I end up with x times. So I cross multiply at x times the sine of 52 equals 200 times the sine of 38. Do not type that in your calculator yet. We got to break that habit if it was a habit in geometry. You wait to the very end and type all of it in your calculator at once so you don't have any rounding errors. So we're going to divide by the sine of 52, both sides, and we're going to get our answer for x. Now, how do I type that in the calculator all at once? The first thing I got to do is make sure I use parentheses for this top statement. Okay, so let's see here. I have parentheses 200 times the sine of 38, close parentheses for the 38, close parentheses that I opened right here, divided by the sine of 52, and I should get my answer of 156.26 feet. So x equals 156.26 feet from Nathan and Amy's house. Find the distance between Tong and Amy's house. Now, I know we have this distance here, x now, of 156.26, and the average student, some geometry students would say, oh, we know two sides, let's use Pythagorean theorem to get the third side. That would be wrong, all right, because it's not a right triangle. So we're going to have to do law of sines again, okay? So if we're looking for this distance now, I'll call it y. We're going to use y and its opposite side. And then we got to determine, are we going to use the 156.26 and 38? Okay, because we could, or we're going to use the 52 and 200. Do you trust all of this work more or less than you trust this work is the question. Okay, I'm going to use this angle. So we're going to have the sine of 52 again over 200 because they're pretty much given values for me. And then I'm going to do the sine of 100 over y. Repeat the same process. Cross multiply. Y times sine of 52 equals 200 sine of 100. Divide by sine of 52. Do not type in your calculator until the very end. This is what you type in the calculator. So y is going to equal, okay, now, a little trick here, people, if you want to retype all of that, push second entry, and it'll give you the last thing that you typed in, because some of it's the same. The only thing that's different here is the 38. So I'm going to insert 100, okay, so the sine of 200 times the sine of 100 divided by the sine of 52 saves me a little time, 249.95 feet. So y equals 249.95 feet. And I've solved both A and B. You can use law of sines in only one of these situations. Identify those which you cannot. Explain why not. Do not do any calculations. Law of sines is angle and its opposite side. Here, do we have, look at the angle, do we know the opposite side? Nope, no. Okay, we don't know any angles here. Automatic no. Here, we have an angle and its opposite side. Yes, we can use law of sines. Here, we have no sides, which would be the big no. Again, part of this process is knowing when to use the appropriate formulas. Using the formulas should be simple. Plug and chug. Math notes, fractional exponents. Yeah, this is just a memorization thing. I teach it like this to my Algebra 2. Okay, what's that called? It's called a flower. All right, these are the roots because the roots go on the bottom. This is the flower or the power. Flower power, hey! Okay, that would be the stem or the base, which stays the same. So if I have x to the 1 over n, what's that going to equal? Okay, well the n is on the bottom, that means it's the n root, and the 1 is on top, just like a flower, the power is on top, so it's the n root of x to the first. The second one there I have x to the m over n, same thing, n is the root, so it's on the bottom, it's the root, m is the power, so the m is the power of the x inside the radical. And the same thing works going backwards. Special right triangles, got to know them. Got to know these side ratios here. Okay, you know, you might have learned it as root 3 over 2, 1/2, and 1. Okay, and here it'd be root 2 over 2. Whoops. Root 2 over 2, root 2 over 2, and 1. You could have learned it either way. Doesn't matter to me, but you got to know them. And that's it.